Alright, so welcome back. We're going to start example 2. In example 2, we're going to be determining the slope, again, the slope of the circle x squared plus y squared is equal to 25 at the point 3 comma negative 4. So, determining slope, this is a big part of derivatives. Remember that derivative means rate of change, and rate of change is slope. Remember, from all of chapter 3, we are looking at where the slope is when we take 2 points and push them infinitely close together, right? So we want to find the slope of this, well, I can't say function because it's a circle. Just as a quick recap, a circle is not a function because, one, it doesn't pass the vertical line test, but more mathematically because you can put one input in and get 2 different outputs, and that's not okay. So just so we can get a visualization of what is going on here, let's look at this circle with radius 5. And just you can see right here that if I were to draw a line, if I was to, let me get my pen tool here, give me one second. If I was to take a line and draw it straight down, right, you can see clearly that does not pass the vertical line test. Right, so for the value 3, you can get 2 outputs where one is 3 comma 4 and the other one is 3 comma negative 4. So because of that, this is not a function. So let me just get rid of all those nasty writings. 2 more, there we go. So again, we want to find the slope of the tangent line of the circle. Well, let's talk about what that means more particularly. Let me place any point A, this point A right here, anywhere on the circle. You can move it around and it gets stuck on the circle. And then right here is going to be the tangent line. Well, as you can see, about right here it's 0, here it's undefined, here it's 0, undefined, and then you have all the different slopes in between. Now notice the slope here and the slope here are the same, right? About right here, it's about -1, and about right here, it's also -1. So these two slopes are parallel. You have the same thing going on each side of the circle. Okay, so we want to find the slope at the point 3 comma negative 4 right here. So that is the goal. Okay, so let's go ahead and we can just look at this line at 3 comma negative 4, and we can just kind of at an eyeball we can count the slope 1 2 3 1 2 3 4. So you can see right here that we actually have a slope of 1 2 3 1 2 3 4, making this triangle. We have the slope of 3/4. That's how you graphically would determine the slope, but without a graphing software that's kind of tricky to do. Not impossible, but tricky. So what we're going to do then, see if I can, there we go, exit out. What we're going to do then is we're going to use our knowledge of calculus. So I'm going to break this down into, I think, 3 steps. So here we go. Step 1 is to differentiate. Alright, so that's step 1, differentiate. Now the question is, what in the world do we differentiate? Well, we're going to differentiate with respect to x. You could do it with respect to y, but then you're finding x prime, which doesn't work for slope, because remember, slope is given as m, which is y prime. Okay, later we will talk about how to differentiate and when we should differentiate with respect to x. But for now, respect to y. Respect to x, my bad, respect to x. So we have x squared plus y squared equals 25. And we're going to take the derivative with respect to x, so d dx to both sides. And again, the derivative distributes because the derivative of a sum like I have written, is the same as the sum of the derivatives. So you get x squared d dx plus y squared d dx equals 25 d dx. Okay, so here we go, let's do it. The derivative of x squared is simply just 2x. The derivative of y squared is going to be 2y, because use the power rule. And again, you can think of it like the chain rule, because the 2 comes to the front. And the derivative of that inside piece is, again, dy dx. And then the derivative of a constant is simply just 0. Okay. So now we want to get dy dx all by its lonesome, all by itself. So you're going to go ahead and I'm going to subtract 2x from both sides. And you're going to get 2y dy dx is equal to negative 2x. And then we're going to multiply by 1 over 2y to both sides. So you're left with dy dx is equal, dy dx is equal to negative 2x over 2y. So then dy dx is simply equal to x over y. Now remember, this is very important to keep in your mind that dy dx is equal to m. It is equal to the slope. Okay? I kind of accidentally combined step 1 and step 2. Step 2 actually began right here. Step 2 began right there, which was to solve for dy dx. That was my mistake. Okay? And now for step 3 is to solve using the point given. So we're going to solve this using the point given. Okay? So we're going to take dy dx at x equals 3. Whoops, you don't want to write x equals, because we don't only have an x, we have an x and a y. So it's at 3 comma negative 4. And this is going to be equal to negative 3 over negative 4, which is equal to 3/4. Okay, and for this problem, it just said to determine the slope. So again, there is our answer. This represents the slope of the tangent line at the point 3 comma negative 4. Okay, so we're just going to look at that and make sure we did that correctly. So here I plotted the point 3 comma negative 4 right on the dot, and there I am graphing the tangent line right here, and you can see if I can click it and turn it on. This is in fact 3 negative 4, and the slope of my tangent line is right here at the bottom of the screen, 0.75x, which we know is 3/4. Good. Now for the try. So this is what I want you to try. I want you to determine the slope of the curve x squared plus y minus 1 squared is equal to 16 at the point 2 comma 3. So it's again very similar. The derivative is going to be a little trickier, but that's okay. I know you guys can do it. So right now, go ahead, pause the video, and what I want you to do now is to try to solve it. All right, now that you've solved it, let's just double check your answers and make sure you're on the same page as me. So again, step 1 is to differentiate. Step 1 is to differentiate. So we have x squared plus y minus 1 squared is equal to 16. And again, we take the derivative of both sides with respect to x. And then here we go. So the derivative of x squared is 2x. Now, this is where you really have to use that chain rule, because it's going to be 2 y minus 1 times y minus 1 prime is equal to 0. Okay? So we're going to get 2x plus 2 times y minus 1. And again, the derivative of that inside piece is just the derivative of y, because the derivative of negative 1 is 0. So here you're going to get the dy dx is equal to 0. Alright, so now for step 2. Solve for dy dx. Here we go. So I'm going to subtract 2x to both sides, and you get 2 y minus 1 dy dx is equal to 0. Whoopsie, not 0, negative 2x. I subtracted 2x from both sides. Now, what we're going to do is we're going to go ahead and divide both sides by 2 times y minus 1 to both sides. I know some of your temptation was to distribute out that 2 and have 2y minus 2. I highly advise not to, mostly because you want things to be as factored as they can, so that way you're able to reduce if possible. If everything's not factored, you can't reduce. So these 2's, again, are going to reduce off. And you get negative x divided by y minus 1. And boom, there you go. There's dy dx. Again, recall, this is a slope, right? We found the slope. That's awesome. That's not an easy thing to do, and we just did it. So step 3 is to evaluate. So we're going to take a dy dx at the point 2, 3. And this is going to give me, I'm going to plug negative 2 in, or 2 in for x. And I'm going to plug 3 in for y. And you get negative 2 over 2, which is negative 1. Again, this represents the slope at the point 2, 3. And that's all there really is to it for differentiating both sides when you have multiple letters.